Now let us study refraction of light. Refraction means bending. We see that light travels in a straight line, but when the light rays enter from air to glass, they change their direction. This change in direction is known as the refraction. So today we will study refraction of light. Refraction of light. Now for this we take a rectangular glass block, just like a soap, a glass soap, a glass bar. This is the top surface of the glass, rectangular glass bar. Now we see that when a ray falls in this direction, obliquely on the top surface, let normal be, this be the normal. So we see that this ray is not going in this direction. It's same direction, it is not traveling in the same direction, but it bends towards the normal. Let us make some big figure. So you can visualize more clearly. This be the normal and this be the ray incident. Let it makes an angle I from the normal. The ray bends towards the normal when it enters to the glass cube. This bending of light ray, this phenomena of bending is called refraction of light. Let this be the angle R. So this is the refracted ray. The point may take O. This is AO is the incident ray, and OB is the, this is O, this is the point. OB is the refracted ray. Now we have to know some terminology used in the refraction. The first one is optical medium. Optical medium, the medium in which the ray travels, the light travels. Let it be air, other be glass, other be water, and so on. Now we know the speed of light in the vacuum is, speed of light in the vacuum is V is equal to 3 into 10 to the power 8 meters per second. And this is the maximum speed of light. The speed of light in air is more or less equal to this. Speed in light in air is just equal to this one, a little bit less, but we take it equal to that of the vacuum for study of refraction. So the air, we will always talk about the air, not about the vacuum in the study of refraction. So air is the rare medium, means having the faster velocity, and number second, glass is called optically denser. We will use the term optically denser, denser medium, rarer medium. And water is denser as compared to air, but it is in between the glass and air. It is also dense medium. So speed of light in air is 3 into 10 to the power 8 meter per second. In glass, it is 2 into 10 to the power 8 meter per second. And in water, it is 2.25 into 10 to the power 8 meter per second. What do you mean by optically rarer, optically denser? Dense means the medium presents resistance in the path of the light. It reduces the velocity of light. In this sense, it is called optically denser. So let us proceed further. These are numerical values, and these terms are important to understand the refraction. So now we will discuss about the laws of refraction. This is the glass slab, and this is our incident ray. Say AO, this point be O, and this, if this is the normal N, this is the incident ray AO, this bends towards the normal, this is the refracted ray, take this angle I, angle of incident, this angle is R, angle of refraction, the first law. Likewise, in case of mirrors, in this I and R are not equal. I is not equal to R. The ray is not following this own path. It is not going directly in this direction, but it bends towards the normal. So here R, I and R are not equal. So first law, like that of reflection, first law is taken conceptual. It is conceptual. It is taken that incident ray normal and refracted ray, these are in same plane. Take the plane of the board. So these AO, OB, and this N and dash lie on the same plane. This is first law. Now second law is known as Snell's law. Snell established that these angles, the sine of these angles, he established that sine I upon sine R, a ratio of incident angle, sine of ratio of incident angle and sine of refracted angles is constant. For what constant? For a given pair of medium. Let this be, this one is air and this one is gloss. So for air and gloss, the sin I upon sin R is constant. Let we take another ray, this one angle will change, this will take in this way. If you take another ray, this is, you take more slant. So this is normal, this will go in this direction. So here this I and this I are different, this R and this R are different. Even then, this sin I upon sin R is equal to constant, and that constant will be equal for a given pair. This is the second law. And this constant, we denote it by n. And this is, n is called refractive index. Refractive index. किसका? Whose is refractive index? Of second medium with respect to first medium. Then this will be 1, yeah, A to G, air and glass. Then this is the refractive index of glass. Why we have taken the refractive index of glass? Because air is taken as a reference. Refractive index of air is taken as 1. So where n is written, the second, it is the refractive index of the, always for second medium. Okay, let us proceed further. Now we will discuss the effect of refraction. In our daily life, we see many effects of refraction, like a stick or pencil held obliquely and partly immersed in water appears to be bent at the water surface. A pool of water appears to be less deep than actually. Let us first establish these facts. Let this is the water surface. The water is filled up, and this is the bottom of the pond. This is the bottom. And this is the water surface. This is the water surface. Now, we will take that when we see the bottom, when we see the depth of the pond, it appears, the depth, actual depth appears, it appears shallow, means the actual, this is the actual depth. Let it will be H. Then this bottom will appears here, somewhat here, means it appears as red, means this is H dash. we feel, when we see through the water, we come to know that the depth of the pond is only h dash. So this is our virtual depth. Virtual that I see. Virtual depth. Virtual depth is less than actual depth. This is due to the effect of refraction. Now let us establish this, how it happens. Let a coin is put here. Let this be a coin. A coin is here at the bottom. Then what happens? Let us use the other ink. When the rays of light from the coin, take this is how we see the things. When the light rays from an object is reaches to our eyes, we come to know that there is a thing. We see the things in this way. Now, as we read, I have studied that this is the incident ray. The light ray starts from here and reaches here at the boundary of two surfaces, where the two surfaces meet. This is the interface, this is the boundary of, this is the water level. So this side is air and this is water. Water is denser as compared to air, means optically denser. Here we use, in later we will come to know that actual mass density, the mass density is higher as of one medium as compared to the other. But the matter having the higher mass density is actually optically rare. So this light reaches here, and as the law of refraction, this will be the angle I. It falls on the boundary. Now it goes into the air, so it will be diverted away from the normal because it goes in the air. So here it goes in this way. This is the refracted ray, and here angle R. Here in this case angle R will be greater than angle I because this medium is rarer, air is rarer. So when we see from here, we take our, when we see this is our eye. When we see this ray coming from here, so we will feel that this ray is coming from here in the straight way, the extend way, this will come here. Let us take the another ray. So this coin will appear somewhat here. This will be the position of the coin. If we take another ray, and this will be normal, then this ray will be as per, this will be I and this will be R. The both ray will not be parallel. This will go in this way. Here it is normal, here it is R dash or this by I dash. But the Snell, the second law will follow. Sin I by sine r will be equal to the sine I dash upon sine r dash, and this will be equal to the n here g to a. Yeah, from the rays start from a denser medium and go into the rarer medium. So what happens when a person looks from here to these ray seems coming from here to this, we will see that the coin is put here, and virtually we feel that the depth of the bottom is here. This will be the bottom, virtual bottom, the virtual depth. So virtual depth will be this one that we visualize from our naked eye, because these rays starting from here seems start from here. Why? Due to the effect of bending of rays. So this is one of the effect of refraction. Now in the similar way, how a stick which is partly immersed in the water seems to be bent, mudi hui, is not straight. Let this will be the water surface, and let this is an stick. AB. This is the actual position of the stick. Now, when we visualize the stick, what happens? Take a ray. How we see the things? Again, the question is how we see the things. The reflected ray or illuminated body, luminous body है तो उस स्वयं it produces its own light, or a thing which is illuminated by the light from other sources. So what happens? The light ray starting from here, a light ray starting from here, incident at this point, and this is the normal. And what happens? This is water and this is air. This is the boundary. So it bends away from the normal. So this is the angle I, this is the angle R. Now, what happens? If you see this ray, it seems to coming from in the water, it seems coming from this, along this line. If you take another ray to form this image, or you take a vertical ray, a ray starting from point B, the actual stick point, it goes here. So it is normally strikes the boundary, so it is not deviated, it goes ever. So here the both ray cut here. So this will be the point B dash. यहाँ लिख देते हैं, इधर फिगर बना देंगे B dash. This will be the point B dash. ये point. This point will appear here. You can take another ray. And this is the boundary. For for making the image. So this is the boundary. At the boundary, this will be the normal, and it will go away. It will be bent away from normal after emerging. So this will go here. And if you put your eyes here, so this ray seems coming inside the water. This seems to be coming along this line. ये आपको दिखाई पड़ेगा. This ray from here, you see actual path of the ray is this, but you will visualize it. It seems to coming from. आपको महसूस होगा कि it is coming from along this line, because light travels in the straight line. So when you will see that light is coming from this point. So the image of point B will be here. So actually the stick, this will be the virtual, let me see. So this half stick, you will see this, and from here you will see this. Actually you will see your stick is bent at here, at the boundary. यहाँ से टेढ़ी हो गई. It is not straight. You will feel that stick is bent at this boundary. So this is the effect of refraction. Other things also given. Stars appear twinkle on clear night, because the light coming from the stars crosses so many mediums. Sometimes it is optically rarer, optically denser as compared to one another. There are layers, so many layers of the air when it enters in the atmosphere of the air, Earth, in the Earth's atmosphere. So it crosses the layers of air which are having different optical density. So stars, the light coming from the stars is not continuous. It appears that it is coming in the part. So stars appears twinkling. Okay. Now let us take some questions so that this theory may be clear. Very few questions. Take carefully. A ray of light goes from a rarer medium to a denser medium. What is the question? Goes from rarer to denser. It bent towards the normal or away from it. When it goes from rarer to denser means, let us assume that it goes from air to glass. Air is rarer and glass is denser. This is glass slab or bar, and when the light rays, this is air, it's a rarer medium, and this is glass, denser medium. So what happens at the normal? It bends towards the normal. This is the answer. Bends towards the normal. If, second question, if ray of light goes from a denser medium to a rarer medium, इसका उल्टा, तो डेंसर से रेयर में जाएगी, इसी को उलट लीजिए. लेट इज दिस रे starts from here, yeah, and a denser medium to, so what happens, the original path is this, so what happens, this is normal, this goes, it deviates away from normal, so denser to rarer, so away from normal, away from normal, and इसका opposite rarer to denser, denser में जाएगी तो towards the normal, bend ray bends towards normal. Take some questions. Array of light traveling in water emerges into air. First traveling in water and emerges into air. Draw a ray diagram indicating changes in the path. Okay. You have seen already. This is water. This is water surface. This is water. Here is air in this side, air, and in this side, water. This is water surface. What happens? Below side of line is water. Take a ray. This is the ray. It goes in this direction. It is normal. It is water is dense, and this is a rare medium air. So the rays after emerging from water, जब water से निकलेगी, it will come out of the water and will enter into the air at the boundary. It bend away from the normal. This will not follow. This is this original path. They away, इस तरफ चली जाएगी, away from the normal. But this is I. Always angle from the normal. But this is R. R will be greater than I. These questions will clear your theory. Array of light traveling in glass emerges into air. State whether it will bend towards the normal or away from the normal. Very easy. Glass to air, away from the normal. Let's take some good questions from this book. What is meant by refraction of light? Draw a level diagram to show the refraction of light. You have seen some good questions. Questions of high order. Which of the following diagrams shows the ray of light refracted correctly? Okay. There are some diagrams, 5 diagrams. Now you have to know, we have to tell what is the correct diagram. This is the water pond. The water is filled up. And here, the normal, the ray comes here, and it is shown that it bends towards this is water and this is air. W for water, this is air. Now examine whether it is true or false. Which is denser medium? Water is denser. This is the denser medium. Dense. And this air is a rare medium. What happens? It is seen that it bent towards the normal. So incident ray is this I, this is R. Here, the ray coming from medium first, the water, and enters into the air. It should go away from. So this is incorrect. The figure is incorrect, not correct. Incorrect figure. Second one is made. This is the boundary, this is the glass, this is the normal, this is the figure made in the book, this is air and this is normal. It is shown that this is the ray coming at the boundary, and when it enters into the glass, this goes in this way, away from the normal. This is I, incident ray. This is air, this is glass. So this figure is also incorrect because incident ray and refracted ray. Refracted ray bends towards the normal when it enters a dense medium. So this is also incorrect. Your rules will be clear from these figures. And glass to water. Very interesting. This is glass and this is water. This is the boundary and this is the normal N. In figure it has been given that a glass and water. This the ray. It is shown that this ray is coming. Incident ray is this. And it bends towards the normal. This is its original path, but it bends towards the normal. Normal की तरफ bend हो गई थोड़ा. This is I and this is R. Now examine what is the rule. A ray coming from, in this case, the glass is in water and glass. If we compare, this is dense, glass is dense and water is rare. When you compare glass with water, this is rare medium, this is dense. Now the ray enters from a dense medium to rare medium. It should refract away from the normal. So it is incorrect. The figure is incorrect. Another figure, water and glass का दिया है. This is the boundary. This is water. This side is water, and this side is glass. Now this is the normal, and a ray coming from this side. First medium is water. Incident ray reaches boundary here, traveling in water, and enters into the glass. It bends towards the normal. It is given. Whether it is true or false. Naturally, if you compare, so this is rare medium, this is glass, glass is denser. So this, for pair of mediums, the first one is rare and second one is dense. So it is correct figure. It bends towards the normal. I is greater than R. it bends towards the normal, so it is correct filter. Correct. Okay, now these questions will clear your concept of refraction, laws of refraction. Now, the next question, very interesting. A vertical ray of light strikes the horizontal surface of some water. What is the angle of incident? What is the angle of refraction? A vertical ray of light strikes the horizontal surface of water. Let the water, this be the water surface. The water is filled up naturally. Let this be a pond, the water is filled up. The question is, a vertical ray of light strikes the horizontal surface. This is the horizontal surface. Naturally, the water surface will be horizontal, and a vertical ray strikes. This is the incident ray coming and strikes at this point. This is the boundary. What happens? Think carefully. What is the law of refraction? Since it strikes normally, it will pass normally. This is the refracted ray. So this one is the refracted ray, and this one is the incident ray. This is air and this is water. So this is I, this is R. This is incident ray. Why this happens? Let us examine. This is very important. Now it is the typical question. This is the very simple process is very simple. When a ray strikes the boundary at 90 degrees along the normal, it will not change its direction. Why? Let us find out. What happens? Here, the wave theory of light explains these things. The wavelet. This will be the glass surface. This is a rectangular piece of glass. Now what happens when the ray passes normally? So what happens? The ray is in the form of wave. तो वेव की स्पीड मैं सीधा बना के बताता हूँ आपको, थोड़ा लंबी वेव बनाता हूँ. दिस इज एक्स एक्सिस, दिस इज वाई एक्सिस. द शाइन वेव इज दिस वेव. तो यहाँ तक ये जो होती है, दिस इज कॉल्ड वन कंप्लीट साइकिल. तो दिस इज कॉल्ड वेव लेंथ. वेव लेंथ. दिस इज डिनोटेड बाय लैम्डा. यहाँ तक ये दूरी from O to A, say B. OB is the one wavelength called lambda, and the velocity is given by the wave velocity is given by lambda by t times the distance divided by time. This is distance and divided by time. This is the definition of velocity. तो दिस इज द वेवलेंथ. तो एक वेवलेंथ जितनी लंबी है, तो व्हाट हैपेंस? लेट दिस बी द axis along which the wave is coming. या मैं उल्टा बना देता हूँ. This wave is coming in this direction. It is air, and this is glass. When it enters the glass, glass is the denser medium as compared to air. So what happens? कोई चीज dense है, तब it will resist the flow. So what happens? The speed of light in glass, the speed of light in air, V air is 3 into 10 to the power 8 meter per second. The speed of light, it is 2 into 10 to the power 8 meter per second. It is less in this. So what happens? This is the wave. So here it comes. So here this wavelength becomes less. This छोटा छोटा travel करेगा. This. So what happens? From here to here, this is lambda. One wavelength, this is distance. Let it takes 1 second. So from, in this case, from this point when it enters at the boundary to this is the complete cycle. This will be lambda dash. So here in the glass the speeds becomes less. So what happens